Hello, good day. Once again, you are welcome back. Today, in today's class, we're going to look at introduction to indices and the basic law and its operations. So here, let's take a look at what we have here. We have a x raised to the power of a, and in indices, the x here is referred to as the base, while the a here, if it is 1, which is singular, is either called power index or exponents. If it is more than one, we refer to them as powers, indices, or exponents. So, in this very essential, especially indices, is something that is indispensable in basic mathematics. Okay, here let's take a look at some of the laws and their basic operation. Now, if we have x raised to the power a times x raised to the power b, and the base here, as you can see, they are the same. Once the base are the same and the basic operation is multiplication, all you need to do, you take the base as 1 and add the exponent or powers or index. Okay, that's the first law. The second law that has to do with division. If the basic operation is division, so long as the base are the same, you take the base as 1, you subtract the power here, which is the numerator, which is a minus b. Number 3, if we have a negative indices, s raised to the power of minus a can also be written as 1 divided s raised to the power a. This is how a negative indices is written. So once you have a negative indices, it is just 1 divide the base raised to the power of the exponent. So you remove the negative sign. Okay. Now we have root indices, s raised to the power b over a. If the power here is a fraction, so all you need to do, you take the root of the of the denominator of the powers to base x, then raised to the power of the numerator of the power. Okay, now this becomes the a root of x raised to the power of b. So you have to use a bracket to indicate it. So we have, for instance, we have a negative power to a base. It can also be written as 1 divide the a root of the base raised to the power of b. Now, if the exponent or the power of the base is 0, so the answer is simply 1. Okay, number 7, if we have x over y raised to the power of a, it simply means that individual base here, which is the one inside x, we raise to the power of the exponents that is outside. Similarly, y raised to the power a. Okay, so this is s raised to the power a divided y raised to the power a. Then number 8, we have x times y or raised to the power a can also be expressed as s raised to the power a times y raised to the power of a. Okay, now let's look at 9. X raised to the power a divide y raised to the power b or raised to the power 1 over n. This one can simply be written as s raised to the power a times 1 over n divide y raised to the power b times 1 over n. So this simply means that if an expression like this, all you need to do, the power outside here, we will have to multiply the power inside for both numerator and the denominator. So this becomes s raised to the power a over n divide y raised to the power b over n. So if we have number 10 here, s raised to the power s over y or raised to the power minus a, here once something of this nation, all you need to do is to revert the denominator to become numerator and numerator to become denominator, and you remove this negative sign so that the expression becomes y over x or raised to the power a. This is how to do the basic operation. Note the following: x plus y all raised to the power a is not the same thing as x raised to the power a times plus y raised to the power a. Similarly, x minus y raised to the power a is not the same thing as x raised to power a minus y raised to power a. Now let's take a look at some of detailed examples here. So simplify the following. Let's look at number 1. We say a raised to power n times 2 raised to power 2n divide 4 raised to power 3n. Now all we need to do here, we know the basic concept of indices. All the base must be the same before we can do the appropriate operation. So here we express 8 raised to power n as well as 4 raised to power 3n as a common base of 2. Okay, so 8 raised to power n is the same thing as 2 raised to power 3n. So 8 is simply means 2 raised to power n, and the n here we multiply the new power, which is 3. Similarly, 4 raised to power 3n is the same thing as 2 raised to power 2, which is 4. 2 raised to power 2, which is the same thing as 4, times the power 3n. This becomes 2 raised to power 6n. Now this becomes 2 raised to power 3n times 2 raised to power 2n divide 2 raised to power 6n. So putting all this one, replacing a raised to power n with this 2 raised to power 3n and 4 raised to power 3n as 2 raised to power 6n. Here we see that all the bases are now made the same. So since the bases are the same, we cannot adopt the common laws and put them into operation. So this becomes 2 raised to power 3n plus 2n minus 6n. So this is multiplication, is plus, and this is division, is minus. So 3n plus 2n, that gives 5n, minus 6n, and that gives minus n. So it becomes 2 raised to power minus n. And remember that from one of the law of indices, this is also written as 1 divide 2 raised to power 2n. So the whole of this expression is equal to 1 divide 2 raised to power n. Now let's look at the second question, number 2. 16 raised to power 3n divide 8 raised to power 5 over 3n times 4 raised to power n plus 1. So we will also express all this term here using a common base of 2. So for instance, 16 raised to power 3 over 4n can be written as 2 raised to power 4. 16 is 2 raised to power 4. We now have to multiply it by the power. So here 4 divide 4 here, and the whole expression becomes 2 raised to power 3n. Now you know that 16 raised to power 3 over 4n is the same thing as 2 raised to power 3n. Now let's look at 8 raised to power 5 over 3n. 8 is 2 raised to power 3, multiplying the power here times 5 over 3n. So 3 cancel 3, and it becomes 2 raised to power 5n. Now similarly, let's look at 4 raised to power n plus 1. This one can be written as 2 raised to power 2, which is 4, multiplying the power n plus 1, and this becomes 2 times n is 2n, then 2 times 1 is 2. Okay, so we will replace all those things that we have expressed as using a common base of 2 into the expression, and this becomes 2 raised to power 3n divide 2 raised to power 5n times 2 raised to power 2n plus 2. Now the bases are now the same, so we can typically make use of the laws. So here, this is 2 raised to power 3n. This is division, become minus 5n plus, here this is time, become plus 2n plus 2. So here 2n plus 3n, that gives 5n. Then we have a minus 5n here plus 2. 5n minus 5n is equals to 0 plus 2. So it becomes 2 raised to power 2 is equals to 4. Now let's look at number 3 question. 16 raised to power, 6 raised to power half n times 12 raised to power n plus 1 times 27 raised to power minus n divide 32 raised to power half n. Here the base, here they are not the same, but we have to reduce each of these expressions to a base that is capable of trying to take into cognizance all the figures given. Okay, here, like for instance, 6 raised to power half n is the same thing as 2 times 3 is 6. close the bracket, raised to the power, which is half n, which becomes 2 raised to half n times 3 raised to half n. Now for 12 raised to n plus 1, 12 can be written as 4 times 3, and 4 can also be expressed as 2 raised to 2 times 3, close bracket here, raised to n plus 1. So this power n plus 1 will affect everything here. This becomes 2 raised to 2, open bracket, n plus 1 times 3 raised to n plus 1. So here, this becomes 2 times n is 2n, 2 times 1 is 2. So this becomes 2 raised to 2n plus 2 times 3 raised to n plus 1. For 27 raised to minus half n can be expressed as 3 raised to 3 times minus half n, and it becomes 3 raised to minus 3n over 2. Then for 25 raised to half n can be expressed as 2. Like 32 is the same thing as 2 raised to 5 times the power half n. This becomes 2 raised to 5n over 2. So we put them into the expression, okay? And eventually this becomes this. All we need to do first here, we pick out those ones with 2, 2, 2, and with their respective sign. So 2 raised to half n times 2 raised to 2n plus 2. Here we have a divide 2 raised to 5n over 2. Now for those with 3, it's just all multiplication. This becomes 3 raised to half n times 3 raised to n plus 1 times 3 raised to minus 3n over 2. Okay. Now since for 2 we have a common base, here we operate 2. 2 here, we put all the necessary operation. This is times become plus, half n plus 2n plus 2. This is division become minus 5n over 2. For 3, so 3 raised to half n plus n plus 1 plus open bracket minus 3n over 2 as the power here. Okay, now if you observe carefully here, this is fraction half n, this is fraction minus 5n over 2, but this is a whole, so this one means divide by 1. So the LCM of this whole fraction is 2. So here we do the long line here. So 2 divide 2 here is 1. 1 times n is n. Here 2 divide 1 here is 2. 2 times 2n plus 2, we close bracket, minus here 2 divide 2 is 1. 1 times minus 5n is minus 5n. That is for 2. Now let's look at 3. The exponent here. The common, the LCM there is also 2. This is n plus 1 is a whole number, means divide by 1. So here 2 divide 2 is 1. 1 times n is n. Plus 2 divide 1 is 2. 2 times n plus 1. This becomes 2 into n plus 1. Close bracket. 2 divide 2 is 1. 1 times minus 3n is minus 3n. Now let's do the necessary operation with the exponent n plus 4n, because 2 times 2n is 4n, then 2 times 2 is 4. So n plus 4n is 5n plus 4 minus 5n divided by 2. Now for the exponent of 3 as a base is n plus 2 plus 2n minus 3n. So here this becomes n plus 4n is 5n minus 5n plus 4, all divide by 2. Here the exponent here is 3 minus 3n, 3n minus 3n plus 2 divided by 2. Now if you look at this, what is left here is just 4 divided by 2. So 4 divided by 2 is 2. So 2 raised to 2 is 4. Similarly here, what is left here is 2 divided 2, which is 1. So 3 raised to 1 is also 3. So become 4 times 3 equals 12. Okay. Here the whole of this expression now is equals to 12. So this is how to make use of the basic laws of indices in the operation of given number when the expressions are expressed in indices. Please, if you like this video, help me subscribe to my YouTube channel. If you have any suggestions, please you can put it on the comment section as well. Have a nice time. See you in my next virtual class.